88% of American adults have at least one of the markers of metabolic syndrome.
88% of Americans are metabolically unhealthy. There was a study at the University of North Carolina showing that 88% of Americans are metabolically unhealthy, that they have at least one criteria for metabolic syndrome. So we are in a crisis, a metabolic crisis.
Here's what I couldn't understand. Why, with all our medical advances, with all the pills, surgeries, guidelines, and diets, do these numbers keep rising? Why are more people getting sick with chronic illness, not less? Heart attacks in people with normal cholesterol, strokes in people with healthy blood pressure, diabetes in people who weren't even overweight. It didn't add up. What I uncovered was shocking. It was shocking how simple it all really is. This is the silent killer.
Many rejected the cholesterol heart disease link because so many patients were dying of coronary heart disease despite so-called perfectly normal cholesterol levels. Of course, as I've detailed before, having normal cholesterol levels in a society where it's normal to drop dead of a heart attack isn't exactly saying much. Ideally, we want to get our total cholesterol well under 150, since having high cholesterol levels in your blood is thought of as the only direct atherosclerotic risk factor. All the other things, smoking, high blood pressure, diabetes, inactivity, obesity, just exacerbate the damage caused by the high cholesterol.
Cause inflammation, and the more statins you took, the more you block toll-like receptors, and the lower the inflammation went. Statins lower inflammation.
Virtually all chronic disease, when you look at the roots, when you go right down and say, well, why does chronic disease happen? The answer is chronic inflammation, okay? What do I mean by inflammation? Stress. Stress on the organs, stress on our blood vessels over a period of time. And what happens is when our bodies are stressed like this, the bodies react, our vital organs react, our blood vessels react, and that reaction over a period of time can trigger changes. The blood vessels are subjected to low-grade stress over a long period of time, and because of that, changes occur in the blood vessels. They become less stretchy, they become harder, and they are more prone to developing thickening of the blood vessels. And as the blood vessels get thicker, they get irregular, calcium, cholesterol, these things get stuck in the blood vessels, and the lumen of the blood vessels progressively starts getting narrower and narrower.
Uric acid dramatically increases the production of these inflammatory chemicals. Uric acid increases risk for metabolic disease. An interesting article was written back in 2016, and it was entitled Uric Acid in Metabolic Syndrome, From Innocent Bystander to Central Player. One study that came out in 2009 in the journal Arthritis and Rheumatism followed 90,000 people, I think 42,000 men, 48,000 women for 8 years. And it noted that in the individuals whose uric acid levels were above 7, which is incredibly common, that those individuals had a 15% increased risk of what is called all-cause mortality. That basically means dying from any cause. They had a 39% increased risk of what we call cardiovascular mortality.
You might be wondering, what exactly is metabolic syndrome? Well, think of it like this. Metabolic syndrome is not one single disease, it's actually a collection of warning signs. In 1999, the World Health Organization defined metabolic syndrome by having a collection of 5 risk factors, and top on that list is insulin resistance, and at least 2 others: high blood pressure, high triglycerides, low HDL, central obesity, or otherwise known as the beer belly. If you're driving a car and three warning lights came on, you'd be concerned to the point of getting to your car to the garage, right? The sad reality is most people don't blink an eye at these warning signs.
Metabolic health has become such a serious problem in this country and really worldwide. And the fact is, most people don't know about it. So you have at least one of those criteria that you mentioned of metabolic syndrome. But those 5 criteria, I would say, are somewhat outdated. We can look much deeper at metabolic health, and we can actually predict the transition from health to pre-disease.
The big question is, what's causing all these warning signs to rise together steadily since the 1970s?
Learned about uric acid and something called gout, where people who ate rich food would get a painful problem in their toes and would be unable to walk. This is not your grandfather's gout-related uric acid.
I've been a nurse for 30 years. I believed, like most of my colleagues, that gout was just an inconvenient form of arthritis. It's painful, yes, but it's simple. You take colchicine, you rest, drink lots of water, and then move on. I was wrong. Almost dead wrong. Literally. Gout isn't just about a swollen joint. It's a signal that your body is already struggling with deeper metabolic problems. The same ones that lead to heart disease, stroke, and dementia. Here's what's really happening though. Gout is caused by high uric acid. But uric acid isn't just about gout. It's tied to high blood pressure, insulin resistance, high triglycerides, fatty liver. In other words, metabolic syndrome. Few doctors connect those dots. Fewer still tell their patients. In fact, if you've had gout more than once a year, like several times a year, you're likely prescribed allopurinol to lower uric acid. But here's the clue no one talks about. It also lowers blood pressure. That's not a coincidence. It's another piece of the puzzle. Uric acid drives inflammation, insulin resistance, metabolic disease. The research is clear, but mainstream medicine is still catching up. Metabolic syndrome is the foundation of heart disease, diabetes, stroke, the biggest killers we face. Uric acid is a root cause. It's not being recognized widely yet, but the evidence is piling up. And if you've had gout, consider it your warning bell. Your body isn't just dealing with painful joints, it's telling you something far more important. I ignored my own warning signs. In 2023, I had a heart attack, and looking back, the signs were all there. Gout wasn't the problem. It was the first symptom I had of the fire that was already burning inside of me.
For more than 99% of our time on this planet, the production of uric acid from fructose was a life-saving survival mechanism, especially during times of food scarcity. Fructose, which was very rare, would allow our bodies to make more fat, increase blood sugar production by making us insulin resistant, even raising our blood pressure as a hedge against dehydration. And for an awful long time, for hundreds of thousands of years, that was a survival mechanism. 2 decades of really intense research globally that uric acid is not just a happenstance, it's a central mechanism that is worsening those very metabolic issues that we need to rein in. We didn't have fructose much. These days, of course, fructose consumption has gone through the roof. We eat now more than 1,000% increased fructose consumption going from 1970 to 1990. The average American is consuming 55 pounds of sugar a year. And so we are constantly stimulating this survival mechanism that's telling our bodies, prepare for winter, prepare for food scarcity, make fat, store fat, lock it up, make more glucose to power the brain, raise the blood pressure because you might not be able to find water. So this is what we call an evolutionary environmental mismatch. And The idea that fructose and its downstream metabolite, which is uric acid specifically, is an issue well beyond gout was written about just very recently. That's 1898 by a Dr. Alexander Haig, publishing a book about all of these other aspects of uric acid. In 1898, uric acid being related to headaches and mood issues and a variety of other non-gout related disorders. But it really took researchers about the last 2 decades, led by somebody here in the United States, Dr. Richard Johnson. I actually interviewed him just yesterday, to really bring to light this notion that here is a central player. It's not just about understanding your blood sugar, where that is moment to moment, which we have the technology to do, but it's all about fructose, not just the fructose that you eat, and we'll talk about that a little bit later on, but this primary metabolite of fructose consumption, which is uric acid. That's our task. Our task is to first identify that and then do everything we can to rein in this uric acid production, which is the danger signal to our entire physiology to get ready for winter.
What exactly is uric acid? Uric acid is a natural byproduct when the liver breaks down purines. If you've read up on gout, you know what purines are. Purines are compounds as a result of a breakdown of DNA and RNA from every living cell, both humans and plants, including those in our bodies of our own. Our bodies undergo constant renewal from the breakdown of old cells, getting rid of invaders like bacteria and viruses that are in our bodies. This all creates purines, but for some reason our bodies create higher uric acid levels from animal sources compared to plant-based purines from beans or vegetables. That mechanism and reason is still being studied as to why that exactly is. Red meat, seafood, and organ meats generate more uric acid than plants in general. Animal products contain saturated fats, heme iron, and glycation end products that are inflammatory in themselves, that adds fuel to the fire that is starting to burn. Our modern life is anything but normal, for which our bodies are not designed for. Purines are also found in alcohol, foods high in fructose, the same fructose that is found in processed foods that are all the rage these days. But if our bodies weren't designed for this modern life, how did we get here?
Yeah, interesting. With my first book years ago, Dr. Gundry's Diet Evolution, I had a whole part that great apes only gain weight during fruit season. And my editor said, oh, don't be ridiculous. And there's an entire book that I have in my office strictly about great apes depending on eating fruit, which only happened once a year in the jungle, to gain weight for the winter, whether that was a dry season, a rainy season, a cold season. And you go into that beautifully in your book, and it's nice to see somebody else saying, look, this was our survival mechanism that we inherited from our cousins, the great apes. And you're right.
That's right. And if there's anything that could have happened to these primates that could have allowed them to make a little bit more fat, then they would have been selected for in terms of survival. And the difference was a mutation, a genetic mutation that took place about 14 million years ago. A genetic mutation where actually it was a series of mutations in the genes that code for an enzyme called uricase. That's the enzyme that breaks down uric acid. So they lost this function. They lost the ability to break down uric acid, and their uric acid levels went up. And that gave them a little bit of an advantage. It's not that they became obese. They just had a little bit of an advantage, a superpower, having a little more body fat. All humans, every one of us, has inherited that uricase mutation. Hence, the uric acid levels of humans are 4 to 5 times higher than that of other mammals.
I want to stop for a second to point out what many people still do not realize. You and I are kind of talking about fructose. And most people somehow don't equate table sugar with fructose. But you and I know that table sugar is sucrose, which is half glucose and half fructose. Can you elaborate on that? How did we miss that messaging?
Not sure how we missed it, but the point is that in that 55 pounds of sugar that we're consuming a year, half of it, as you correctly state, is fructose. But your point is well taken that when we're eating table sugar, that's 50 immediately broken down to fructose and glucose, and the body looks at them in a completely different manner. We tend to think, well, fructose, glucose, their sugars pretty much handled the same way. Couldn't be more diametrically opposed. The absorption of fructose and its metabolism are very unique. The consumption of energy molecules in the metabolism of fructose, the fact that fructose acutely doesn't involve insulin, and the fact that fructose is then metabolized to uric acid really differentiate it dramatically from glucose. And that would be probably not so terrible if the more than 60% of foods at the grocery store that carry a barcode didn't have added sweetener, and that added sweetener wasn't 50-50. It was much higher, is much higher in fructose because it's derived from high fructose corn syrup that has, as a minimum, 55% fructose, but oftentimes even more.
So back in the 1970s, people in America were really worried about food prices. They had been a few years where food cost a lot, and some families didn't have enough money to buy all the food they needed. So President Nixon came up with a plan. He wanted to make sure food stayed cheap so people wouldn't go hungry and the government wouldn't look so bad. He asked a man named Earl Butz, who worked as a Secretary of Agriculture, to fix the problem. Earl Butz told farmers to grow as much corn as possible. Lots and lots of corn. He said, get big or get out. That meant only the biggest farms could survive, and they were told to plant corn everywhere. Now, when you grow way too much corn, you got to figure out what to do with it. And scientists found a way to take corn and turn it into something sweet called high fructose corn syrup. It was cheaper than sugar and could be used in sodas, cookies, cereal, and other processed foods, and companies loved it. They started adding high fructose corn syrup to everything because it was so cheap and made food taste good, even if it wasn't even healthy. So even though the program started to stop food prices from going up, it ended up creating a new problem. Lots of sugary processed foods filled with high fructose corn syrup. And that made it easier for people to get sick with things like obesity, diabetes, and other health problems.
But let's be clear, this notion of making fat from fructose is seen in a lot of animals. How do you think the hummingbird survives these 1,000-mile epic journeys? There are times when the hummingbird has 40% of its body weight fat. And if you want a hummingbird in your backyard, what do you put out? You put out a bird feeder full of sugar, and it makes them fat. Whales, camels, for example. And the other interesting thing about it, and I mentioned it earlier, is that this body fat is a survival mechanism, not just for the energy store that it represents, but also because when we burn fat, we produce two things: carbon dioxide, which we exhale, and water, metabolic water. So storing extra body fat is a hedge against dehydration. I mentioned the camel. Camel can walk across the desert. They have a hump, and what's in that hump? It's not like there's a tank of water in there. It's fat, and that allows them to survive. Whales have so much blubber because that's where they get their metabolic water, like the hummingbird, and like we do too. So when our bodies have a sense that we're becoming dehydrated, we make more fat. And how do we know when we're becoming dehydrated? When our sodium level goes up. That's the relationship then between eating a lot of salty pretzels while you're watching the playoffs and getting fat. Your body thinks that it's dehydrated, and the hedge against dehydration is to make body fat because it's converted into water. The main missions of Drop Acid is to identify these sources of fructose and two other things that raise uric acid: purines, which are the breakdown products of DNA and RNA in certain foods, and also some forms of alcohol are known to increase uric acid. But by and large, these days, it's this incredible signaling to our bodies to make ready for winter by making fat induced by our incredible consumption of fructose that is really at the center of the problem. I mentioned earlier that it's beyond the fructose that we consume, that we have within our bodies a mechanism that is also going to help us survive, called the polyol pathway, whereby we create fructose in our bodies even when we're not eating fructose. We convert glucose, blood sugar, into fructose. And what might stimulate that would be things like thinking we're dehydrated. So when serum sodium goes up, even though we're not eating fructose, or we may be, our bodies take glucose and make fructose out of it, because that's a surefire way to make more uric acid, to make more body fat, because that body fat can be water when our bodies think we are dehydrated. That is the relationship then between dietary sodium and obesity, dietary sodium and diabetes, for example. So this activation of this polyol pathway, I'll tell you another interesting way that it's activated. It's activated by something called hypoxia, meaning not enough oxygen in the blood. And it doesn't have to be dramatic. A little bit of lowering of the blood oxygenation saturation will trigger this pathway and make more fructose in the body. Why is that important? I mean, who gets hypoxic? Well, you don't have to climb K2 to get hypoxic. If you have sleep apnea, which is exceedingly common, you become hypoxic at night and you stimulate this pathway, which makes your body gain more weight, which does what? Makes your sleep apnea even worse. So it becomes a vicious cycle. You dramatically increase your risk for obesity, diabetes, and yes, sleep apnea is related to risk for Alzheimer's disease and coronary artery disease, for that matter, as well. Now we have the mechanism. Now we understand how that happens. So there are interventions that become available to us at multiple places along the way, like a CPAP, of course, but also recognizing this connection to fructose formation and uric acid. So anything that feeds into the uric acid production, we want to talk about. And interestingly, the metabolism of the three things that you just mentioned, the purines, the alcohol, and even the fructose, are all enhanced in the presence of higher levels of uric acid. Think about that for just a moment. This is what we call a feed-forward cycle. Normally, we have checks and balances in our bodies such that when things start happening, then at the end of the line, there is something that happens that tends to turn it back down. This is just the opposite. This is uric acid raising the alarm, saying we've got to keep this whole thing going because we're going to starve or we're going to become dehydrated. Now, alcohol is metabolized in exactly the same way as is fructose. It requires ATP, it depletes our bodies of energy, it challenges our mitochondria because of that energy depletion, and forms uric acid. But there are variations in the type of alcohol that I think are very relevant. We know, for example, that at least as we look at what are called food frequency questionnaires, in other words, asking people what they eat, we find that women who drink wine have a slightly lower uric acid. Men, it's pretty much neutral. But beer tends to be a big player. Why? Because beer contains alcohol, but it's also very rich in purines because it's made from yeast. So you're getting two very powerful inputs into the production of uric acid. So that uric acid then is causing the body to make more fat. Now we fully understand what's behind the beer belly. The mechanism is that we're targeting the uric acid pathway twice. So the third input, purines, are the breakdown products of DNA and RNA. So in that regard, certain, for example, organ meats, liver, kidney, a certain small fish like anchovies and sardines have higher levels of purines. So if a person has elevated uric acid, are things to consider to remove from the list, or simply eat less of. It turns out that as it relates to purines, about 2/3 of them are actually produced within your body. 1/3 come from food, 2/3 produced as you break down muscle fiber when you exercise, etc. So again, the big player is going to be fructose. So incredibly increased in our modern world. We used to say the standard American diet, then we started to say, well, no, the Western diet, because it kind of spread around the world. Now it's the global diet. This change in dietary patterns has become prevalent across the entire planet. And as such, we are seeing these metabolic issues exploding around the planet. And now we have a new tool, and that is measuring your uric acid and getting it under control. So this is the new tool for all of us, for you and me, and certainly for all of your viewers today. It's not the end all, but it's a powerful new tool in the toolbox, and that is bringing your uric acid, first identifying where it is, and then bringing it under control.
Literally study after study after study, over and over and over, showing the link is now coming to light. Dr. Alexander Haig, Dr. Perlmutter, Dr. Johnson, and Dr. Gundry certainly connected the dots. We now know that lifestyle plays a key role in chronic illness. Smoking and vaping not only create hypoxia, but they also have countless chemicals in the product that liver must process, creating high uric acid levels. Likewise, conditions like sleep apnea create hypoxia. Red wine has been shown to have anti-inflammatory polyphenols, but it contains alcohol that drives uric acid production, negating any health benefits. High salt intake has been known to increase the risk of high blood pressure because it causes dehydration, similar to the effects of coffee, and alcohol consumption. Anything that causes dehydration creates high uric acid levels. The simple act of overeating creates inflammation, and that in turn creates uric acid. There have been studies linking gingivitis to heart disease. The cause of gingivitis is chronic inflammation, and the driver for inflammation is uric acid. We were taught that reducing calories leads to weight loss. But if that were true, then every diet that lowers calories would work. However, they don't. They don't work for everyone exactly the same. And instead of thinking in terms of reducing calories, think in terms of lowering uric acid. The link is now clear. From gout to chronic illness, and the culprit, uric acid, is now named. Despite all these studies showing the link so clearly, why hasn't the medical community acknowledged the connection? And yet, the silent molecule has shown up consistently in all these metabolic pathways. These chronic illnesses like heart disease, stroke, diabetes, dementia, and Alzheimer's are big money makers for the pharmaceutical business, trading money for control rather than seeking to eradicate the cause. Despite decades of education, medical advances, and studies dissecting every possible diet, the number of people living with chronic illness keeps rising, and alongside it, uric acid levels keep climbing. The key driver of metabolic syndrome is uric acid. It ignites the spark. Our modern lifestyles fuel the fire. Do you think that food industry didn't even notice? Money feeds the uric acid machine, both in the food industry and the pharmaceutical industry. Do you believe the pharmaceutical industry wants to find an end to chronic illness? They're making tons of money, and there's no profit in prevention. Since the 1950s, sugary drinks have exploded in popularity and brought metabolic diseases along for the ride. High blood pressure, obesity, diabetes. Even as soda consumption dropped after 2015, metabolic diseases kept rising. Clearly, the problem runs deeper than just sugary drinks. In the 1980s, the diet food craze emerged, sparking a massive processed food industry selling. Promises of health and weight loss. But instead of solving the problem, they poured more fuel onto the fire. This graph tells an interesting story. As sales of better-for-you products rose, diet sodas, protein bars, low-fat snacks, so did global obesity rates. Still think processed foods have declined? Ultra-processed foods, packaged snacks, ready meals, processed meat, sugary cereals, and so-called health foods have risen in lockstep with obesity, insulin resistance, fatty liver disease, and type 2 diabetes over the past 3 decades. So the question becomes, if this fire is fueled by modern choices, what happens when we choose differently? What if the answer isn't just in another diet, but in reducing what drives uric acid in the first place? Could the future of health, yours, mine, all of ours, be found by reclaiming the simple truth we've overlooked for decades? Eat whole foods, move daily, hydrate deeply, rest fully. Reduce the fuel, lower the spark, and live better.